8.4. All right. So we're going to take those rules that we learned last class, and we're going to actually apply them to some math problems now to actually evaluate some expressions. So up here, your first type of problem you're going to see is where I'm going to give you like some values, like I'll tell you what log base 10 of 5 is, and then I'll tell you what log base 10 of 25 is, or something like that. And then you're going to use what you know to find another number that you don't. Another thing we're going to do is we're going to solve some more log equations. We already started doing that, but these ones are going to be a little bit more advanced, so you'll see how that goes. All right. Go ahead and write down your directions in number 1. Now, your directions are really important for these problems because they actually tell you some key information that you're going to be using. Now, before we get started here, guys, let me just kind of talk to you about what we're doing. Here's the thing. I know what log base 10 of 5 is because they tell me what it is. What is log base 10 of 5? 0.7, right? Or 0.70. And what is log base 10 of 8? 0.9. So here's what I'm going to do. They're asking me something I don't know. Log base 10 of 40. But here's the cool thing. Is there any way I could turn that 40 into an 8 and a 5 because I know what those are? What would it be? How can I make 40 somehow an 8 and a 5? 8 times 5, right? So watch. I can rewrite that 40 as something I know. 8 times 5. Why would I want to do that? Well, we had a law of logs last class that told us that multiplication can be rewritten as what? Now, I'm separating these because I know what they each are separately, right? What does log base 10 of 8 equal to? Look at your directions. It's 0.9. I'm going to put a 0 in the front so you guys know there's a decimal there, okay? The decimal, a lot of times people don't put zeros. I'll put it there for now. And what about log base 10 of 5? 0.70, right? Now, we can just add these together, and we're going to get 1.6. So, in other words, I use something I know to find something I don't know. Okay? That's the basic gist. So you want to look at the number that they give you here, and you want to ask yourself, is there any way I can break that number up into the numbers they give me? In this case, it's 8 and 5. Go ahead and write down number 2, please. Go ahead and write down number 2, please. Log base 10 of 64/25. All right, well, look at the numbers that they're giving us. 64 and 25. I need to turn those into 8 and 5 somehow. Can you guys fathom how that would be? There you go. We can rewrite the 64 as 8 to the second power. You guys agree? And I can rewrite the 25 as 5 to the second power. Now I've got 5s and 8s. All right? So let's go ahead and use our laws of logs to isolate the 8 and the 5 here. So the fraction's going to become what? Fraction becomes subtraction, right? And then what do the powers become? They become multipliers, right? Okay, so the base is 10, right? Let me fix that. So used to writing the log base A. All right, there you go. All right. Now, I've got them separated. I've got just the 8 by itself and the 5. So now we can plug in what we know. What is log base 10 of 8? 0.9, right? Look in your directions. Log base 10 of 8 is 0.9. And then log base 10 of 5? There you go. So we just have to do some math here 2 times 0.9 is 1.8. 2 times 0.7 is 1.4. And if you subtract those, you would get 0.4. If you guys are having kind of a hard time with your decimals, then you're allowed to use calculators. And in case you didn't notice over there on your homework, I'm specifying bring a calculator. It's going to be a very sad day if you don't have a calculator next class, so bring a calculator. Okay, now before we do number 3, you guys can go and write it down if you want, but I want to tell you something that's kind of tricky about some of these. Actually, it's good news, but it's tricky because it's not obvious from the directions. From the direction, it looks like the only 2 numbers I'm trying to get are what? 5 and 8. But guess what? There's another number that they don't even mention in here. And I want to show you what it is. So, as a side note, if you guys want to add on your notes here, I'm going to change slides really quick. Watch this. Let's say that I have log base, I'm just going to put a letter there because it could be anything. Let's say I have log base b of b. What does that equal?
1.
Well, we're shouting out answers. Why is it 1? It is equal to 1. Why is that? What is that? That's it. Good. Wow. All right. So if we make, let's say we don't know what this equals, right? You could put x. I'm going to put question mark. So I don't know what that equals for now, but we can totally drop that log by doing left, right, middle. Right? Change it to exponent form. So let's change this to exponent form. Ready? What's left? Right? Question mark or x, whatever you want to call it. And middle. Okay, so let me ask you this. What's the exponent on the b on the right there? 1. How can these two be equal? We cross off the bases? What's the question mark equal to? And therefore up here, what is log base b of b? 1, just like you guys were saying. Now, notice that since I put a letter there, that's true for any number. Anytime the base, doesn't matter what it is, matches the number you're taking the log of, it equals 1. It doesn't matter what it is. Log base 5 of 5 is 1. Log base 6 of 6 is 1. It doesn't matter. So why am I telling you that? Well, for these problems, not only can you use the 8 and the 5, but what's my base? So we're also going to be allowed to use this. Log base 10 of 10 is equal to 1. So you might want to add a little note there for yourself. So the reason why I stopped there to introduce you to that fact is because on number 3 you're going to run into a problem. There's no way we can write 80 as a 5 and an 8. Okay? You're going to have a problem there. If you broke down 80, you could do like 8 times 10, and you could break the 10 apart into 5 times 2, but we can't use a 2, right? We don't know what log base 10 of 2 is, so you can't use that. But the good news is we can use 10 and 8. Because we know what 8 is and we know what 10 is, so here's how I would rewrite this one. Log base 10 of 8 times 10, right? Because I know what 8 is and I know what the log of 10 is. So, here we go. Log base 10 of 8, and this is going to become addition because it's multiplying it. Log base 10 of 10. Now, what is log base 10 of 8? 0.9. And what is log base 10 of 10? 1. So what's 0.90 plus 1? It's 1.9. So be aware that you can actually use 3 numbers. You could use the log of one number, the log of another number, and you can use the base. Okay? So you can use 3 different numbers. All right, so here's your problems to try. Now notice that your directions are different than mine. So you guys have log base 3 of 2 and log base 3 of 5. So let me ask you this before we get started. What 3 numbers are you allowed to use here?
8.
You can use 2, 5, and 3. So the tricky one we're going to be allowed to use is this. Log base 3 of what? 3 equals 1. So you can use that also as well as these. So I'm going to go ahead and let you guys try those. Good luck.